I now want to look at the idea of partial derivatives. Let's consider the function f of xy equal to 3x squared plus 4y squared minus 2xy. And let's further suppose that y is equal to 1. In this case, this becomes 3x squared plus 4 minus 2x. And this is a function in two variables. I can look at its derivative. That would be 6x minus 2. And then if I wanted to suppose x is equal to 2, I could figure out what the slope of the tangent line is. This would be 12 minus 2, or 10. The idea of what we just calculated, we have our three-dimensional function over here on the right. And when we let y equal to 1, we trace out this curve that looks like a parabola. If we were to match that in 2 dimensions, it would look like the graph here on the left. And by finding the slope of 10, we found that this graph, the slope of the tangent line at x equal to 2 is equal to 10. So we essentially found the slope of one of the tangent lines for this function. For the same function, let's suppose x is equal to 2. Then this becomes 3 times 2 squared, or 12, plus 4y squared minus 2 times 2 times y. And once again, this is a graph in 2 dimensions. We could look at taking the derivative. So this will be 12 plus 8y minus 4. If I then let y be equal to 1, this time I have the derivative of 12 plus 8 minus 4, or 16. So a different derivative this time, because the idea is this derivative is moving in a different direction. I'm looking at a different function. And this is the basic idea of partial derivatives. Each partial derivative arises at a point as the derivative of one variable function is defined by fixing one of the coordinates. To calculate partial derivatives, we essentially hold one of our variables fixed. We treat it like it's a number and take the derivative of the other. In other words, if we have a function f of xy, fx is the derivative when y is a constant. Then we take the derivative with respect to x. Fy is my derivative when x is a constant. I treat x like a constant and take the derivative with respect to y. And these are my partial derivatives. We can also note these as the partial derivative of f with respect to x using this notation here, or the partial derivative of f with respect to y. Let's consider this function, f of xy equal to 2x to the 4th minus 5x cubed y to the 5th. For fx, I'm going to treat y like it is a constant. So the derivative of 2x to the 4th, I would bring the 4 down to make 8 and subtract 1 to make cubed. Here the y is treated like a constant, so I'm just going to take the derivative with respect to x. Bring the 3 down and subtract 1. So I have my x derivative as 8x cubed minus 15x squared y to the 5th. If I want my y derivative, 2x to the 4th does not have any y's, which would mean the derivative of that piece is 0. The next piece, I would bring the exponent of 5 down to make negative 25, and then subtract 1 to get y to the 4th. So now I have my x and y derivative. Next, let's look at f of xy equal to x squared y squared over x squared minus 2. This time I'm going to need a quotient rule. I have the derivative of the top. We're only taking the derivative with respect to x, so I'll bring the 2 down and subtract 1 from the exponent on the x, times the bottom, minus the top, times derivative of the bottom, and the derivative of the denominator is 1. All over the bottom squared. On the other hand, if we want f sub y, it might be easier to think about this function as x squared over x minus 2 times y squared, because this entire term here, this x squared over x minus 2, is going to be a constant, so it's going to be treated like a constant. I would bring the exponent for the y down and subtract 1, or 2x squared y over x minus 2. As one more example, let's consider f of xyz equal to xy cosine of x minus z. This time I'll have 3 partial derivatives: fx, fy, and fz. For my x derivative, y and z are numbers, so I am going to have to use the product rule here since I do have 2 x terms. That would be the first times the derivative of the second. The derivative of cosine is negative sine of x minus z, and the derivative of x minus z would be 1. Plus the derivative of the first, the derivative of xy would just be y, times the second. So we have negative xy sine of x minus z plus y cosine x minus z. For f sub y, the x and the z are constants, so this is a number times y times a number, so the derivative would just be x cosine x minus z. For fz, the only z is inside the cosine. The derivative of cosine is negative sine, so this will be negative xy sine of x minus z. And then the derivative of the z on the inside is negative 1. So I would multiply this by negative 1 again. In other words, xy sine of x minus z.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.